Delta III SSBN Project 667BDR. We're adding a letter to each one of these. Delta III has 3 letters, BDR. Project name is Kalmar, which is Russian for squid. And this is the subbrief. All right, so our story for the Delta III begins in February 1973 when the Mechanical Engineering Design Bureau builds a new missile, the R-29R. It's going to be a brand new missile. It's a little bit taller, a little bit bigger than the previous missile. So they approach Chief Designer Kovalev and says, hey, we got this new missile for your Delta series. Why don't you go ahead and make us a new Delta to fire this R-29R? And sure enough, that's what he does. They take the Delta design, they rip out from the design paperwork the complex, the missile complex, and they put in the new missile complex called the D9R complex, which is a lot taller. It rides up a lot higher topside than the previous one and is designed to launch the R-29 missiles. A few other things that they added, they improved the fire control system for the salvo launch so that they could launch all 16 missiles in one salvo. If you remember, the Delta II had that unique old school from the Delta I fire control system where they could only launch 12, but they had 16 missiles. So they had to launch 12, rebalance everything, repressurize everything, and then launch the last 4, right? So obviously that wasn't ideal. So they did improve the fire control system so they could launch all 16 silos or tubes in one salvo. They have the VM4 reactor, which is the same reactor on the other Deltas, but the vessel's a little bit bigger. So it holds 16,000 liters of primary coolant now, what that means is they can move more coolant or heat more coolant and send that coolant to the steam generator, which would create more steam. But it's also the same engine room. So they're not really getting any more power from it, but they do have the ability to send more steam to it. So if they're not careful, they could break it, basically. But they do have a larger vessel around the reactor now, up to 60,000 liters of coolant. The Tobel M2 is the new underwater navigation system. That's the inertial navigation system. And the M2 can go 2 days, or I'm sorry, more than 2 days between fixes. The Tobel M1, they had to fix their position on the globe every 48 hours. Now we can go longer than that. So it's a significant upgrade, which means they can stay submerged for longer periods of time without surfacing or at least coming to periscope depth and getting some kind of astral fix from the stars. And they also have the Schmel fathometer. Now, this is a very complex fathometer that actually maps the bottom directly below the submarine. It doesn't look out very far, but what they have is some very detailed charts. Russians have very detailed oceanographic charts of the Arctic region, Norwegian Sea, and other places around the globe, but we're talking about this region primarily. And what they can do is they can do like a star pattern, crossing the same point over and over again and looking at the area around it a few hundred meters. And they take that data, the depth, the slope, the bottom composition, and then they go to their chart and they have an idea of where they're at, but they want to see exactly where this point that they're crossing over and over again is on the chart. And they can get a fix using the Schmel fathometer doing that method. This is the first high resolution fathometer the Russians have that has the ability to do this bottom mapping for location purposes. So very good tool. They no longer need to come to PD to get a fix. They don't need to get a GPS as they would today with a radio antenna. They can stay submerged and, every 3 or 4 days, just refix their position without ever coming to periscope depth. Very powerful. Force multiplier. Okay, the R-29R is the SSN-18 NATO named Stingray. It is the third missile there, the one that's in the very center of your chart. As we go through the deltas, we are slowly working our way through all of these. We only have one more to go, and that's the Delta IV, which we'll be doing next. But for right now, we're talking about the R-29R, the SSN-18 Stingray, was operational in 1979. A caveat to that is the original Mod 1, which was obviously the one they tested first, was technically operational in 1977, but the full range of variants was operational by 1979. It is a 2-stage liquid-fueled rocket. It has multiple warheads. It can have a 1.45 megaton warhead or up to 7.1 megaton warheads. And there was 3 versions of these. It's 14.6 meters tall. It is 1.8 meters in diameter. The 8 kilometer mod, I would say, got an 8,000 kilometer mod 1 range. That's with the 1.545 megaton warhead. Or the mod 2, the mod 3, has a shorter range of only 6,500 kilometers, but it has multiple warheads. The mod 2 has, I believe it's 3 warheads. The mod 3 has 7 warheads, 7.1, smaller nuclear warheads. It has the same accuracy because it has the same azimuthal astral correction that the earlier, R-29D had. So it's 1 kilometer accuracy there. Okay, so the R-29 submarine launched ballistic missile tested at Kasputzen Yar Missile Facility. It's the SSN-19 or SSN-18 NATO name. Comes in 3 versions. And there we see that the Mod 2, which has 3 warheads, each one of those is only 0.2 megatons. And here you can see them loading one of the missiles, one of the variants, into a test tube, if you will. And they're getting ready to do a launch. That is in Kasputzen Yar. All right, so the Delta III SSBN by the numbers. She's a little bit bigger because we're putting a bigger missile deck on her. So 13,700 tons submerged. She's 157 meters long, 11.8 meters a beam. With the missile housing, now she goes up to 19 meters tall. So the beam is the widest point of the submarine at or near the water line. But if you wanted to measure from the keel to the very top of the missile deck, that would be 19 meters. And I added that in there just to give you an idea of how much larger the missile housing is in the Delta III from the Delta II. It's significant. Her speed is 24 knots, which I believe is only 1 knot less than the Delta II. So they're, in that range. They'll never go 24 knots. I mean, there's no point, unless they're running from a torpedo, they're not going to be going 24 knots. Even though in the picture we show the 7-bladed screws, she also began her life with the 5-bladed screws, but they installed the 7-bladed screws after the 1990s on the ones that were still operational. Test depth is 400 meters. That seems to be the standard unclassified test depth. We know they can go deeper, but typically they stay, 400 meters or shallower during normal operations. Launch depth is near the surface, so there's really no reason to go that deep, unless they're trying to hide, or they're under ice. They need to be that deep. Okay, at sea days is about 80. The officer and crew are 130 warm bodies, and they have the Millennia M satellite communication system, which is the same one they had on the previous version. It just works, so why bother with it, right? They have the 2 VM4 reactors that we talked about, 2 shafts, 5 7-blades apiece. Again, they began their life with 5 and they went to 7. They never mix 5 and 7 at the same time. Let's make that clear. You either have 2 5s or you have 2 7s. All right, so the D9R missile complex has 16 missile tubes. The names of the 3 versions of the missiles are the R-29R for the single warhead 0.45 megaton. R-29RK is the 3 warhead 0.2 megaton, and the R-29L is the 7 warhead 0.1 megaton apiece. And those are designed for soft targets like cities and stuff. You may say, well, 0.1 megaton isn't a lot. Well, it's not a lot compared to maybe some mega bombs, but it'll still screw up a city. So, but they normally went underway with the R-29R and R-29RK. The 7 warhead one was deployed, but it was not often. All right, so we have 4 53-centimeter torpedo tubes. They did carry a complement of 8 shoulder-launched, man-portable Strela SAM missiles that they would take up to the sail during surface transit. And that's just to deter any, maritime aircraft from coming around too close. It's a very short-range missile. Think of it like the American Stinger. They have the Rubicon sonar, the Tobel M2 navigation systems that we talked about, and the Cascade radar, also known as Snoop Tray. And I always love hearing Snoop Tray come in from the ESM operator, because I knew that whenever we had Snoop Tray, we had submarines in the vicinity, and they were on the surface, obviously using the radar. They were going to dive, and as soon as they dive, they were going to come into my territory. We were going to snap them up, and we're going to trail them for a few days, run some tape on them. Yeah, submit that That's right. Submit that to the Office of Naval Intelligence. So Snoop Tray, one of my favorite radars. Always love hearing Snoop Trays out there. All right, let's talk about Delta III missile hatch sequence. Some great photos here from our friend Saturn X. Starting on the left, moving to the right, they begin opening up the missile hatches. Now, one thing I want to point out is all the missile hatches appear to begin opening at about the same time, so it's not one at a time. But look at the hatch all the way on the front of the submarine on the left-hand side. You can see the front hatch, hatch 1 we'll call it, is almost all the way open immediately before any of the other hatches begin to come up or have any severe, any progress. So that one is, slammed open right away, it looks like, and then the other ones are coming open too. This tells us a couple things. First of all, the D9 missile complex is cut up into 2 compartments. You have the compartment 4 with 8 missiles, compartment 5 of 8 missiles. 2 should be completely independent systems. But in this case, if they are independent hydraulic systems, the hydraulic systems are cross-connected, so they act as if they're one system. And because missile hatch 1 popped open so fast, we know that the pressure from the hydraulic system 1 can't feed all the silos, all the missile tubes at the same time. So it doesn't have enough pressure. Whether it's 3,000 pounds or 4,500 pounds hydraulics, whatever it is, it's not enough. But the next thing we can tell is that it comes in from the forward of missile compartment 4 and feeds its way backwards. So the pressure hits tubes 1 and 2 first, pops those missile hatches open, and then whatever pressure energy is not used by 1 is used by 2 or 3 and 4, and then 5 and 6 because it's used in pairs, all the way back to the very last hatch. Now that's kind of a small, kind of an engineering something I noticed, but whenever you're doing analysis of these pictures, it's little details like that you want to make a note of and submit to the people that use this information. You have, there's a very clear difference in the responsibility of the analyst, which is what I was in the Navy, sonar analyst, and the people that use that information for either engineering or tactical information. The rate at which the hatches open is important. It's a small piece of the puzzle of how long it takes to launch a missile, to prepare the missile for launch. And one of the big advantages we had when we were tracking them is whenever they began missile preparations, it took them a long time. By the time that Delta III came around, it was under 7 minutes to go from absolutely nothing to launching the missile, under 7 minutes. But in the Deltas 1 and 2, that was upwards of 20 minutes, So while they're getting better, measuring these hatch times is just a small component of that formula. But as you can see, as more and more of the hatches are kind of lifted out and they have some leverage because they're pivoting on that hinge, they begin to all kind of open at the same time. But if you're thinking about, working for the government as an analyst, that's the kind of mindset you need, is look at the details and then try to find out why is that hatch on the left-hand side fully open before any of the other ones even begin. And that is my analysis of the hydraulic system of the D9R. Okay, here's some pictures from the top side looking at the hatches all the way fully open. I want you to notice, for those of you that haven't noticed yet, I'm going to go and point it out. Hatch 9 didn't even open. So there's obviously a casualty, or that hatch is tagged out for maintenance, but they've only got 15 of the 16 hatches open right now. Now, if you look at the right-hand picture, you see the little what do you call them? I don't know, bars that are coming up from topside. Those bars screw in, and then you loop a little white safety rope around it just to keep people from accidentally walking into a tube that could be empty and could fall down, 11 meters to the bottom. That would hurt, 19 meters to the bottom. The thing that's funny about these rods that hold the safety line, the exact same rods are used by the United States Navy. The company that makes these little safety lines is selling to the Russians and the Americans. They're double dipping, those guys. But anyway, I thought that was kind of unique how they seem to use the same safety lines that we use. And I'm sure it's just a coincidence, but little details like that made me chuckle when I saw these pictures from Saturn X. All right, let's get on with our first hull. K424. Keel was laid 1974, and she was launched, that's out of the construction building, rolled back into the floating dry dock, and that floating dry dock takes her over to the pier side where she submerges. She's pulled out of the floating dry dock and tugboat over to the pier. That's what the launching process is. From there, she goes on sea trials, where in 1976, she promptly runs aground and damages the hull a little bit. So not a good start to the Delta III program. All right, in November of 1976, after she repairs the damage from the September collision, she does the first successful launch in Soviet history of the R-29R missile from a submarine. And she's finally, with that missile test successful, is commissioned at the end of the year, New Year's Eve, right? No, just before that. 30 December 1976, she is commissioned. 1977 to 78, she does extensive missile testing for the R-29R, and that makes sense. This is the first missile boat with this missile. They want to, work out all the kinks and the bugs. They've got 3 variants to test. So she's throwing a lot of missiles over to Kamchatka from the Barents Sea and White Sea right now. In 1980, she test launched from the Norwegian Sea. And the reason why I point this out is if you look at the top of a globe, you can go from the Norwegian Sea to the Kamchatka Peninsula without really violating anybody's airspace. It's kind of like you're going over the Arctic airspace that nobody really owns. But the Norwegians always got real upset because every time they launched something from the Norwegian Sea, they would claim that the missile body went or violated their airspace. And you know what? Maybe it did a little bit, but if you were a dum-dum civilian looking at the nightly news and they show the Norwegian Sea and they show the globe from the side and the Kamchatka Peninsula is way over here on the right, it looks like the missile trajectory would go over Norway and Finland and Sweden and everything else, all the other countries. So it was real easy for the Norwegians to make these protests going, hey, stop launching over our airspace, when in reality, they were launching these over the Arctic Circle. But so that's just something to look out for whenever you see protests in the future. We see this right now with North Korea violating Japan's airspace, launching short-range ballistic missiles into the Sea of Japan. And, that's an entirely different case, but know that their complaints are kind of, political, more political than anything else. Okay, in 1982, they surfaced 14 times through the ice. They basically wrote the book on Arctic launch operations. So they would just surface through the ice. They'd go topside with their big boat hooks and just push off these large, iceberg-sized pieces of ice off the hatch. The hatches could actually open with up to like 6 feet of ice on top of them. And some of these pictures coming up, you'll see that ice. It's huge. And they flop open the hatches and toss the ice off like it's nothing. But they also send the crew members up there to push as much of the ice off as they can. And, here we have the R-29 missile test. Again, she tested 4 of the R-29Ls, 6 of the R-29Rs, which have the 3 warhead, 0.2 megatons, and 12 of the R-29RKs, which have the 7 warheads. Very busy boat. Continuing with the K-424, in 1983, she dry docked in Nurpa shipyard. That's up there in the Kola Peninsula by Murmansk for some, dry dock time. In 1984, a missile patrol on the equator goes down the Atlantic side. So what she's doing down by the equator, even though she wouldn't normally have her missions down there, she's testing the navigational system, because the navigation in the Arctic and the navigation on the equator are 2 different methods of navigation. And this is the lead boat in a brand new version of the Delta. So she's basically doing sea trials as an operational submarine, making sure that everything is copacetic. And so she demonstrates that she can cross the equator and not lose her bearings. In 1984, while loading missiles, a mechanical failure occurs and kills 2 sailors. This happened in port while loading missiles. It's not explained what the mechanical failure is, but it probably had something to do with the hoisting system, I assume, and sadly took 2 sailors' lives in 1984. Very sad incident happening while loading weapons. Loading weapons is very dangerous, and it's not from explosions. It's from dropping the flipping weapon on you. Okay, in 1986, while launching a missile from the pier, which is insane that they do this, but they launch missiles from port, the ejection failed and the missile landed back on top of the submarine. And to make things even better, the Red Banner fleet, the top admiral Gromov, was on board at the time. So after they successfully launched and ejected the missile, the rocket motor didn't ignite, so it just freaking slammed back down on the deck, broke into a million pieces. The liquid fuel immediately ignited, caught everything on fire topside, scorched topside. But because all the other hatches were closed, no smoke got inside, it pretty much burned topside up, but it didn't damage any other missiles. And I'm sure they had a chat with the admiral after that investigation happened, because of all the times for the rocket motor to not ignite, being surfaced in port with the admiral, just bad luck. All right, 1986, she goes on a missile patrol near Iceland, which is interesting because she doesn't normally operate out that way. You can rest assured NATO is tracking her every move at this point in 1986. I can confirm that personally. In 1987, dry dock at Sevmash for repairs. And from 1989, after dry dock, to 1992, she has 3 missile patrols. And in 1995, she's removed from service. And in 2011, her reactor is in long-term storage at Saudya Bay. All right, so let's talk about some of these shipyards. We talked about her going into Nerpa shipyard. I thought I would show you where that's at. Again, it's on the Kola Peninsula. It's right outside the Polyarny Inlet, which has, on the south side of the Polyarny Inlet, the inland side, is where Sevmash is, or Severnensk. And Severnensk Machine Shop is in Severnensk. You see Nerpa right there. The Kola Peninsula is clustered with these relatively small, by American standards, naval bases. And they just park little squadrons of submarines at different bases and kind of keep them spread out. So they're not all in one base. They don't keep all their eggs in one basket, if you will. But the basket spans, half the Kola Peninsula, the Russian side of it anyway. All right, so she's in the Murmansk region. That's her address if you wanted to contact their public affairs office. You could actually call them if you want to. I don't recommend that. But if you wanted to write to them and request, what their PAO has for a public release, you could write to 184680 Russia Murmansk region, Nerpa, address it to the public affairs office. You might want to write that in Russian and see what you get. You never know. Even though I do provide you the phone numbers, do not call them. That's not cool. I don't want to get any nasty grams from Russia. Anyway, K441, keel laid 1974. You'll notice that 1974 to 76 was when these submarines were made for the most part. I mean, they will be built all the way up into the 1980, I think it is. But 74, 76, they started pumping these suckers out. Probably, I suspect, this is my opinion, they had already started laying down or had plans and the materials to lay down these keels as Delta IIs when the Delta III program came out. And they were like, well, we're already ready to go. Let's go ahead and start building them, calling them Delta IIIs with the new missile complex. That's why I think 74 to 76 was so busy building Delta IIIs. Okay, so K441, commissioned 1976, does 52 missile tests, 52 of them from the White Sea and the Barents. An insane number of missile tests. This is the second boat of this version, and she's just throwing missiles all over the planet. 1979 to 84, she does 6 patrols under the ice. And in 1986, she's modernized to the Gaz Avora-1 auto throttle. So this is something that the Soviets are famous for. They automate everything. And as of 1986, they're beginning to put the auto throttle on the Delta III. And that is from the control room in compartment 3, up there where the captain's at, the periscopes are at. It's the heart of the submarine. They simply dial a speed, 10 knots, comrade, hit the go button, and the throttles in the engine room let just enough steam into the engine to get 10 knots by log as ordered. And there's not a human involved other than dialing in the speed. It's kind of an interesting thing. Americans don't use that. We probably should. It'd be easier. But this is one way that they can cut down on the number of crewmen that they have, is by automating everything. The torpedo room has been automated since the beginning of time for Russia. That's one of the first things they automated because they don't trust their sailors to handle heavy weapons. Anyway, so 1988, under ice transit to the Pacific Fleet to Krasnikov Bay. This happens a lot. A lot of these Delta IIIs are going to be built in the, Sevmash, the western part of Russia, the Atlantic side of Russia, and within a year or two, going to be stationed in the Pacific. So that 441 is the first one to do that. She's going over the Kamchatka Peninsula, where she serves over there for an unknown number of patrols. We don't have the dates, but she was removed from service 7 years later. So she served in the Pacific for 7 years, obviously with distinction. We don't know what happened to her, and then was removed. And then her reactor is now in temporary storage as of year 2000. I don't have an update after that. So hopefully by year 2020, that reactor's in long-term storage, but was unable to confirm that. Okay, K449, the third one we're building here. Again, 74 to 76 construction time. She immediately does 5 patrols under ice through 1982. In 1983, she has a collision underway with something, but has no damage. And I've checked the American logs. There was no NATO or American entry of a submarine collision in 1983. With a Soviet submarine. We had some collisions with ourselves because we're idiots. But in 1983, they had there was no collision between a NATO submarine and a Russian submarine. So it's possible that they hit a whale. They could have hit some ice. It doesn't mean it was a submarine, but they did have a collision. In 1985, they collided again, this time with an ice keel at 300 feet, damaging the superstructure and multiple systems in the sail. That's like the antennas and the periscopes, things like that. But despite that, she completed her 39-day patrol with limited comms, because even though she had some antenna damage, she didn't lose every means of communication, so she was able to continue her patrol safely. In 1987, she dry docked at Sevmas for maintenance. 1990, she does transit to the Pacific Fleet. 1995, she conducts a patrol in the North Pacific east of Japan. So if you go south of Kamchatka on the map, east of Japan in that region, that's where she hung out for 60 days. In 2001, she's removed from service. And in 2002 to 2003, the United States funds the disposal and long-term storage of the reactor. Now, I want to talk about this a minute because this topic has come up before in previous subbrief lectures, where other countries often fund the dismantlement and safe stowage of the nuclear components of Russian nuclear submarines. And you have to think about this in kind of an ecological and safety way. It makes sense that if Russia is decomming these old submarines and letting them sit by a pier until they rust and sink, they're literally sinking because rust is eating a hole through the steel hull in some cases. That's not good for anybody if that reactor fails and begins contaminating the entire seaboard of whatever country. It doesn't matter what country it is. Even though it starts in Russia, it's not going to stay there. It's going to go around the world eventually. So paying to have them decom these reactors is just the right thing to do. The obvious problem with this program is although Japan, EU to some extent, but the Americans especially, we've been involved in a lot of paying for their decoms quietly without telling the American public about it, is that they obviously take that savings that they don't have to spend, Russia, and they put it back into developing the next submarine and building it. And so we're kind of helping our enemy by protecting the environment. We're doing the right thing, and the Russians are taking advantage of it. And this is going on today. This hasn't stopped. So I just think everyone should be aware of it, no matter what country you're listening to this from, whether it's from Russia or from America or anybody in between. That's what's happening. And if you want it to stop, then you need to, talk to your own leaders about this. I'm not making a judgment whether it's right or wrong. Although I am leaning towards protecting the world. I mean, protect the environment. We don't want these sinking submarines to be contaminating, large swaths of seashore. But that appears to be that's kind of where we're at with this long-term storage. Is Russia builds it, the rest of the world pays for decomming it. All right, construction is assigned to Sevmas Shipyard. Here you can see the construction building. They have multiple construction buildings. The largest one is the white one on the left-hand side there. They have a smaller one there on the other side. I have some pictures of inside these construction shops where they build all sorts of things. They build small boats. They build submarines. It's quite a busy place. Sevmas is famous, one, for quality of work. They're very good engineers and craftsmen at Sevmas, and my hat's off to them because they build great submarines. It's just the maintenance of these submarines that is lacking. If God forbid, if they maintain their submarines as well as they built them, they would be a much more formidable foe. And this is where it happens. Sevmash is the model other Russian shipyards try to meet in terms of quality, production, and scheduling. All right, let's move on to K455. Keel laid in 74, launched in 76, commissioned in 76 as well. In 1979, she transits to the Pacific via the Atlantics. So this is one of the cases where they don't go across the top of Russia, kind of evading the ice along the way. They take the long way around. They go down through the Atlantic, around South America, and then back up through the Pacific. It takes like 2 months to do this transit because it's a long way. But she does it, ends up in Krasnikov Bay. In 1980, 1985, she's in the Pacific. She does 6 patrols. She's refit at Zvezda shipyard. Now, this is a little confusing to me. There's a Zvezda shipyard in Far East Russia, which is by Japan, even though I guess that'd be West Russia. And there's a Zvezda Dalshe shipyard by Sevmash over in the Kola Peninsula. So I'm just going to point out that this Zvezda shipyard is over there by Vladivostok. It's right across the bay from Vladivostok. Okay, 1989, 1998, almost 10 years. She does 4 patrols in those 10 years and is removed from service in 2000. In 2015, a reactor is put in long-term storage. All right, so here's the Zvezda shipyard near Vladivostok in the Sea of Japan. You can see that she's located in a town or city called Bolshiye-Kamen. I've heard this referred to as the Bolshiye-Kamen shipyard, but that's technically not correct. It's the Zvezda. She's owned by the United Shipbuilding Corporation, so this is a private company operating a military shipyard. And they do other things too. They build, large merchant ships, and they do it all. And you can see right there, they have these great assembly slips where they build the ship or submarine. They just back it right out onto a floating dry dock there. You can see at the bottom of the picture, you can see the top of it anyway. And that floating dry dock will take it away from the pier a little bit, submerge it, floating whatever's inside the floating dry dock, whether it's a ship or a submarine. Anyway, Zvezda shipyard. All right, K490. Let's move on. 1975 to 77, she is launched during sea trials, leaking upon the dive due to a pressure hull not replacing a steel plug. There's a plastic plug. Let me back this up. Okay, so there is holes in the pressure hull that you run cables and stuff through during the construction of a submarine. So whenever you're done with the cabling and stuff, you or before the cabling goes in, even sometimes you'll put a plastic plug in there just to keep dirt and stuff from outside the submarine from getting inside the submarine and contaminating the area that you're working on. Because after you run cables through there, in the case of a cable run, you need to keep it clean and then pack it with watertight material, right? Well, one of these plugs never gets used, or they never finish running the cable through it, or something happens where the plastic plug that leads to the outside of the submarine to the inside of the submarine stays plastic. It can't withstand any pressure whatsoever. So the moment they dive, they have a stream of water that goes into the control room, comrade. And they're like, hey, stop that. They put something in front of it. They obviously surface immediately, pull back into the pier and be like, hey, finish building our submarine. They put a steel plug in it to finish making the internal part of the submarine watertight again. Thank God they didn't get any more than a few feet down before they saw the water come in. It wasn't that big of a deal, but whenever an oversight like that happens, it makes you wonder, it's like, well, what else did they miss? So after I just talk about how good Sevmash Shipyard is, they pull something like this. Anyway, they get through sea trials. They commissioned at the end of September 1977. They participate in war games in 1978 in the Barents Sea, and they collide with a Charlie SSGN, have minor hull damage to both. So not a good time for K490 after sea trials. Their first real public war game, they end up colliding with somebody. 1979, they're like, get out of here, go to the Pacific Fleet, so you stop running into our submarines and trying to sink in our Barents Sea. They sent them over to Krasnikov Bay. And in 1984, missile patrol in the North Atlantic is her first actual missile patrol after her commissioning. 1984, almost 7 years later? All right, K490 continued. 1986, she pulls into Zvezda Repair Yard. That's the one we just looked at. And in 1993, she does conduct a successful missile test. And in 2003, she's removed from service. 2006, again, United States comes in with the cash, funds the removal of reactor. You're welcome. It's in long-term storage. Okay, Russia's Pavlovsky Bay and Krasnikov Bay. I just want to show you where these are geographically on the Kamchatka Peninsula, which is that big-ass peninsula that comes down out of Siberia, right across from the Alaska Bering Strait. Now, Pavlovsky Bay is on the actual mainland peninsula. It is the larger base. It has a shipyard and a lot of ships that after they go into their first dry dock period, long-term dry dock period for maintenance or whatever, they'll just stay in Pavlovsky Bay and operate out of there. But whenever ships move from Sevmash and the Barents Sea and are transferred to the Pacific Fleet, they are almost always initially stationed at a Krasnikov Bay, which is a large submarine base as well. Look at it right there on the picture. It takes up a good portion of the little island that it's on. And one of the advantages that it has is that the transit time between Pavlovsky Bay and Krasnikov Bay is about 1 day. So round trip, that would be 2 days. That adds 2 days to their patrol time or at sea time or on station time just by being stationed out of the southernmost submarine base. They're adding at sea time for free, you know. So that's why a lot of them are stationed at a Krasnikov Bay. It's more of a geographical thing. There's more facilities up on the peninsula than there is in the Krasnikov Bay. All right, let's go to K487, another Delta III. This one built 1975, commissioned in 1977. From 79 to 1980, she has 4 missile patrols in the Arctic Sea. 2 patrols of the 4 were a 60-30-60 rotation. And this is where they do that push to, you know, if this was a war situation, this is how you would rotate. And so they practice this. They do a 60-day, missile patrol. They pull in for 30 days, which is enough to do maintenance, restock the food, swap out the crew if there's any swapping going on, retrain the crew if they do the swap, and then go back out again for 60 days. The U.S. Navy does this, and we recently did this with one of our carriers in, I want to say 2017, 2018, a carrier in the Pacific Fleet, United States carrier, deployed from San Diego, went to Japan, which is normally like a 9-month deployment, and then, operated in the Pacific for 9 months, came back home for 30 or 45 days and was ordered back to sea for a full deployment. And it's just to practice wartime rotation to make sure that our supply system and material training can handle that kind of stress. It really sucks for the crew when that happens, but it has to be done. And the Russians are doing it too, just to make sure that they can operate at a wartime tempo. And they do this 2 times between 1979 and 1980. January 1981, fire in the third compartment near Spitsbergen Archipelago. That's in the Norwegian Sea. They use the LOX fire extinguishing agent to put out the fire, but 5 sailors in the compartment are unable to escape and are asphyxiated by the fire extinguishing agent. Again, adding to the kill count of this fire suppression system. At this point, by 1981, this fire suppression system the Russian Navy uses has killed far more sailors than any fire has. It's lethal. And the problem seems to be they have a procedure to seal the compartment, which obviously is a good idea if it's on fire, but they're not letting the sailors in there out. If they don't get out in time, sorry, comrade, you're just going to have to wait until we're done fighting the fire. And it's never enough time. Every Russian sailor, if you've seen pictures of them underway, carries around a portable respirator that has a small amount of air for them. And whether that air is 5 minutes or 15 minutes, I don't know. But I can tell you this, it's certainly not enough. The way the American sailors do it is we have piped air from the high pressure air tanks that are reduced, obviously, so you don't breathe in 4,500 pound air, but you have a ton of air, big ass air supply, forward and aft in the main ballast tanks that feed these emergency air breathing manifolds that are, at waist high level and in the overhead, and they alternate. So that if you're ever in a compartment that you can't get out of, you could always grab an EAB breathing mask, plug it into this manifold, and have hours and hours of breathing. The Russians don't have that system, and it's killing sailors when they have sailors trapped in a compartment full of smoke. It's kind of sad, but that's how they operate. Okay, in 1982, 1985, they do 4 patrols under the ice. In August 1985, they used 2 torpedoes to make a hole in the ice, which is crazy as shooting a freaking ballistic missile from a pier. They shoot live torpedoes underneath the ice, detonate them at about the same spot to break the ice apart, and then they go and they surface through the hole and conduct a missile test. In 1985, for the first time, the escorting Victor, which is a fast attack, surfaces beside her a few hundred meters away, and they're both sitting there on the surface after the missile launch, bobbing around, playing soccer on the ice, looking for polar bears. In 1987, she goes to the shipyard Sevmash, that's again near the Barents Sea on the Kola Peninsula, for maintenance. K-487 continued. After she comes out of the shipyard, she goes to sea again, conducts 3 patrols in 3 years, 1992 to 1994. In 1994, while underway, she collides with B-138, which is a Victor III fast attack submarine. It is not clear if this was her escorting submarine, but it probably was, because the Delta IIIs are going underway with fast attacks with them all the time at this point. It just makes sense, because the fast attack can keep us, Amerikanskis, away, at least at arm's length, while they go and do their missile patrol. It's not stopping us from watching them, but it certainly is keeping us from getting too close to them. Anyway, and you can see the damage there. Pretty significant damage to the forward part of the missile housing right as it reaches the sail is where they bumped. They're very lucky they didn't damage that missile. That could have turned into a real disaster. Okay, 1995, a small primary coolant leak of 30 liters a day, quote, small, is discovered, and they pull into port for repairs. Keep in mind that the vessel carries 60,000 liters total, and they have a feed tank where they can keep feeding, primary into the vessel. But still, whenever you leak a single drop of primary in the American Navy, it's all stop, decontaminate the sailor, even though it's a drop of water. It's a big deal. They do 30 liters a day. It's over a liter an hour gushing into the bilge, and it's a small event. It's just 2 very different perspectives on nuclear safety here. 1998, she's finally removed from service, and in 2011, the reactor is moved to long-term storage. K-44 Raisin. She kills late in 1980. We're jumping a little bit ahead here, but we're going to jump up to 1980, commissioned in 1982, because K-44 is a special boat. In 1983, missile patrols with Victor III escorts are observed again. So by now we're seeing a pattern of that. In 1984, her towed array is damaged by her screws because her auto throttle failed. Remember, we talked about that throttle being automatic. And part of the reason why American navies like to have a man on that throttle instead of it being automated is because of things like this. So they probably threw on a backing bell is what I think happened. And this could have been operator error too, because the auto throttle works in forward and reverse. So maybe the auto throttle did exactly what it was told to do, and instead of going forward 10 knots, it went backwards 10 knots. Anyway, anytime you got a towed body behind you, whether it's a radio buoy or it's a towed sonar array, if you put on a backing bell, you're going to chew up that cable right into the screws like it's a blender. And that's what happened in 1984. 1985, fouled both propellers in a trawler net, just like it had done the year before with its freaking towed array cable. And was towed to port because they had fouled the propeller so bad, they couldn't turn the shaft. No word on what happened to the trawler. Trawler nets do have an automatic breakaway after a certain number of pounds of pressure are put on them, so they don't drag the trawler underwater. But in the 1980s, trawlers, especially in the Sea of Japan, had been pulled underwater by American submarines or Asian, Japanese, whatever submarines, not just Americans. And, injured or killed some of the crew. So, but in this case, there's no entry about what happened to the trawler. We can assume that it simply lost its net. Also, this net could have been lost previously, months ago even, and just drifting around. And whenever that happens, that sounds creepy. Let me tell you about this. I've heard this a couple times. It sounds like wind chimes. And the things that are the wind chimes on these trawler nets, if they're just floating around the ocean, is they have these little hooks, relatively little to the size of the net anyway. And the hooks obviously are made of metal, and they have a hinge that allows them to freely swing back and forth as they go through the water. And so if the net is just floating around and the current, the ocean current, is just kind of pushing the net back and forth, those hooks hang down like wind chimes, and they bang against each other, or they bang against the housing, making this eerie, horror movie like sound of high pitch, nonsense, musical tones almost. And you could recognize it right away once you've heard it a few times, and you just stay the hell away from it because you don't want to get it fouled in your net. But that's what happened to them in 1985. Okay, they completed 6 missile patrols under the ice during the 80s total, besides those incidents. In 1990, her post-dry dock sea trials found damage to the ballast tank vents not sealing, which is really bad. So obviously, whenever they try to blow main ballast tanks, they can't keep air in the ballast tanks, which means water's coming in the bottom, making them negatively buoyant and slowly sinking out. In 1984, she's fully repaired and test fires a submarine launched ballistic missile, becoming operational again in 1984. All right, K-44 Rise-On continued here. In 1997, missile patrol in the Arctic Sea, she's awarded the name Rise-An in 1998. Up to this point, she doesn't have that honorary designation. 1990, while conducting submerged missile test, the rocket separated in 2 parts as it left the tube. So it hasn't even reached the surface of the water yet. It's already broken up into 2 parts. Which obviously it exploded, caught on fire, but it exploded outside the submarine, throwing the missile nose, away from the submarine, but near the vicinity of the submarine. And it was able to be recovered by another submarine later on. Russians have AS, or special submarines, that can go deep, very deep, and pick things up off the bottom. They used one of those submarines to pick up the nose module. Again, it was a test missile. It didn't have a warhead on it, but it does have guidance and other valuable things that they don't want the Americans to come and snag, because we definitely would have done that. So they got it recovered. In 2002, submerged launch on experimental satellite Demonstrator 2. This is a little known program that they had in the Deltas, Delta III, Delta IV, which we'll talk about the Delta IV in the next lecture. But Demonstrator program was to launch observational heliocentric satellites for the military, and they could have been used for civilian use, I suppose, to provide observation or signal intelligence over certain points of the globe at the same point every day. So a heliocentric orbit is a low Earth orbit of a satellite, a recon satellite, that passes the same point on the globe every time of every day. So if they wanted it to pass Washington, D.C. at noon, they could launch that, and every day at noon, it would pass Washington, D.C. And the same satellite would pass, Norfolk at 1 p.m. an hour later. As it slowly goes around the globe every day, it's keeping the same schedule. So Demonstrator 2 was a program to try to use submarines to launch those satellites instead of shore facilities. Now, there's a couple reasons why you'd want to do this. Obviously, it's more expensive to do this, so it's not the ideal choice. But in the event of a war, they're going to take out our satellites, and we're going to take out their satellites. There's going to be a bunch of space junk up there, all blown apart, and, it's going to be a long time before we get mass media communications up again in the event of a real war between China, Russia, and the United States or the EU. Any 4 of those operators, space is gone. You can say goodbye to Netflix. You're going to be doing local broadcasting for a while until we reestablish satellite communications. Well, these satellites, you could start and end a war quickly with a ballistic missile submarine, and after all the shooting's done, launch a few of these satellites to begin communicating again with the Russian military, and have the added benefit of reconnaissance, because that was the main purpose of these satellites. Of course, they had communication capability to share the information, but their primary purpose was recon. Anyway, Demonstrator 2 program, very rare, very little known program that I'm sharing with you here today. For the Delta IIIs, it failed. Every single satellite that Delta III threw into the low Earth orbit either never achieved orbit, which was it in just about every case. And in one case that I'm thinking of, they launched it into low Earth orbit and then they lost it, because apparently that's real easy to do. It's not easy to track things in orbit all the time. Anyway, so that's interesting. Demonstrator 2 program, everybody. 2005, 3 years later, she enters dry dock for modernization and a service life extension. 2008, she's operational again and launches a missile successfully just as a test. She's back to being a ballistic missile submarine in 2008. She transits to the Pacific Fleet, going to be stationed over there for a while, operating out of the Kamchatka Peninsula. She pulls into the Zvezda shipyard. That's the one over there on the Pacific Fleet side in 2011. 2015, she first missile test fire in years is a success. Simultaneous missile test with Barents Sea fleet, but not operational. She returns to the shipyard. So she kind of came out of the shipyard to shoot this test as part of this larger program where they launched ballistic missiles from the Barents Sea using another submarine, obviously, at the same time coordinating a launch with the Pacific Fleet. And that is a command and control war game to make sure that they can launch nuclear weapons nearly simultaneously from multiple fleets around the globe. Anyway, but she's not done in the shipyard, so she goes back. In 2019, she's out of the shipyard. She takes part in war games in the Pacific, Thunder 2019. She launches 2 SLBMs, but were amended after the first flight due to a failed launch. So she's scheduled to launch 2 missiles. The first one fails. They don't even try the second one. And in 2020, as of this recording, K44 is operational in the Pacific Fleet. This Delta III is still out there poking holes in the ocean with 16 missiles on board, doing her thing. That's the K44 reason. All right, demonstrator experimental satellite program. I already talked a lot about this, but here's what they did. And this is not the entire program, by the way. We will continue this discussion when we talk about Delta IV, which has a lot more involvement. But for the Delta IIIs, they took the R-29R, modified it to become a still carrier missile, or STIL, which is the term they used for their rocket program, basically their NASA launching satellites into orbit. So if it's a still carrier missile, it's a orbital deployment missile, or rocket. So they modified the R-29R to carry this payload up into, heliocentric orbit. It simply doesn't have enough energy, though. It doesn't have enough fuel. Like the 2-stage liquid fuel rocket is designed to throw, ballistic missiles, warheads in a suborbital flight to their target. And that's all it has energy for. And that's why these fail. And so it does have a payload of 1 to 3 microsatellites, and that is staying consistent with the 2 of the 3 mods of the R-29R missile that they have. Remember, they can have 1 warhead, 3 warheads, or 7 warheads. Well, they can have 1 satellite or 3 satellites. They try both. They all fail. This program does not work for the Delta III. And the primary root cause of the failure is this missile doesn't have enough energy to attain low Earth orbit. They need another missile. We need a Delta IV, comrade. And that's what's going to solve it. But we'll cover that in another lecture. Okay, the Delta III launched program has been halted after 2002 and goes on to the Delta IV. Something for you guys to look forward to. K496 Boris Olgoblisk. I nailed that. Built 1975, 1977. From 1978 to 83, she does 10 missile patrols in a 5-year period. So that is high tempo for the Russians. That's normal for the United States, but high tempo for the Russians. 1983 coolant leak in the steam generator caused return to shipyard for replacement and upgrade to a new steam generator. It's not clear as to what the new steam generator is. It's probably the OK 700, but it's probably a version of that because they had the OK 700 in the old one. The point is, because they have this larger vessel making more steam, they can upgrade the steam generator to generate the more steam, but they're still limited by the same ship or engine that they had in the other Deltas 1 and 2. They haven't changed that. So all they're doing is increasing their ability to break their own submarine by having so much steam created. Okay, 1984, 1985, they do 5 missile patrols under the ice. This is a hot boat. 1991, she dry docks in Sevmash for an overhaul. She comes out of that a few years later. These dry dock periods are long. We're talking 1-2 years. Then you got a sea trial for another year. It takes a long time to get through these long overhauls. 1995, though, she does a missile patrol. She's operational again. 1997, she deploys off the coast of Greenland and mapped a 70 square kilometer part of the ocean. In 1999, she's awarded the Borisoglovsk honorary name. In 2005, she's launched a spacecraft Cosmos 1, but in 2005, it failed to reach orbit because they're still using the R-29R, from 2002 when they failed this with the previous boat. They're still trying again in 2005. They can't get it. Just can't get it up there. They're trying all sorts of math tricks where they try a high trajectory, a low trajectory, different ways to get the payload in. But if you just don't have enough energy, you don't have enough energy. And that's really what they're faced with. But kudos to them to keep trying. They're trying to find a more efficient way to get it up there. In 2005, she launches another spacecraft with modified airfoils. Spacecraft cannot be found. This is the one that's missing. It could be in orbit. We don't know. So they threw it up there and it never came back down again, as far as I know. Surprised they didn't call that a success. Anyway, K496, the Boris. I'm just going to call it the Boris now. 2008, she's removed from service. 2014, the Kotlas Maritime Assembly. Kotlas is a small town near Severnensk. They bought the outer hull. That normally means the sail. That's where the Fairwater planes are and the bridge is at. They bought the outer hull for 2.7 million rubles, and they're going to make a maritime museum out of it. That was in 2014, 6 years ago. It's probably already a museum by now. So if you're ever near Kotlas, Russia, which is on a river, same river that goes up to the White Sea, past the shipyard, you may be able to see this. They also have a few other things in Kotlas, like they have a large locomotive train. They're big on their museums. They're there at Kotlas. And here you can see the remains of K496 being ripped apart in the shipyard. A lot of those materials, that's a steel hull, is being recycled. That's why you see large parts of it being cut away the way that they are. All right, let's move on to the K506. Built from 75 to 78, she completes 3 missile patrols under the ice from 79 to 80. In 1981, she transits to the Pacific Fleet stationed out of Krasnyannikov Bay. In 1983, she does 2 missile patrols to 1985. In 1990, she heads over to Zvezda shipyard, that's across the bay from Vladivostok, for overhaul. 8 years later, she gets the honorary name Zelninograd. Nailed it. In 2003, she test fires 1 SLBM. That's a success. And in 2008, she launches another missile during War Games Stability 2008. I like the positive name of that war game. A lot of these war games are like, Thunder or We're Going to Kick Your Butt 2019. This one's just called Stability. Like, everybody calm down, launching ballistic missiles. In 2010, she's removed from service, and 2017, her reactor is confirmed in long-term storage. K211, Petrolovsky Kamchatsky. Built from 1976 to 1976 to 1979. In 1980, she completes 2 missile patrols in 1 year. Hot boat, hot running, back-to-back missile patrols in a 12-month period. In May 23rd, 1981, she collides with a U.S. submarine, damaging both. Both return to port under their own power. The United States never acknowledged this collision. But it was pretty clearly a United States submarine. It was a, what was the class? It's a Sturgeon class, a 637 class, pulled into Holy Loch, Scotland about 2 days after this collision with clear damage to the top side of her sail. So there was a collision. I don't know the name of the submarine. Again, it was never officially recognized because the American submarine did not have to surface. They collided. They didn't have flooding. They maintained their trim. So they simply exited the area and returned to Holy Loch. But it most certainly was a United States submarine that collided with them. In this case, the K211 surfaced right away and pulled into port. All right, so 1982 to 1985, 4 missile patrols under the ice. From 1984 to 88, she received numerous awards. These were too many to list, so I just put them all together here. She has Courage of Military Valor, the Pennant of the Central Committee. Central Committee is one of the primary political institutions of Russia. And she has 4 different Challenge Red banners. So different entities inside the government can award them a Challenge Red banner. So you could have like a Challenge Red banner of Sevmast Shipyard or Challenge Red banner of Moscow. You know, she earned 4 of those in 4 years. So hot boat, hot running, you know, making U.S. submarines return to port one way or another, and out there fighting the good fight, being awarded for it. In 1990, she enters dry dock for scheduled maintenance, and in 1998, she's awarded the honorary name Petropavlovsky-Kamchatsky. Continuing with K211, in 2006, she dry docks for maintenance that is not finished. This sadly happens to a lot of Russian submarines, especially after 1992. Where they'll pull in for maintenance, especially if they're on the Pacific side, because the Pacific dry docks don't get as much funding as Sevmast gets on the other side, on the Atlantic side. So she pulls in for dry dock, never seen again, and she never comes out of it. In 2008, she's moved to the Naval Reserve Fleet, which is still kind of sort of an operational platform, has a crew, not doing anything. In 2010, she's finally just removed from service because there's no point funding her, you know, and maintaining her if she's never going to come back to sea again. And then in 2008, the reactor cores are confirmed in long-term storage. In 2020, and this is the first evidence I've seen of this, although it's probably happened before, recycling of precious materials begins from inside the submarine. So, for example, they're going to rip out all the equipment and harvest all the copper and all the rare materials that are built in these computer chips. The cable runs in these submarines are miles and miles long, and the cable runs, for electrical cabling anyway, are all copper. That copper is very valuable. It's also very expensive to strip it out of a cable run and strip the binding out from it. But copper's become so valuable that it's made that process profitable. So now private companies are coming in to the shells of submarines that no longer have a reactor in them because it's been cut out, but you have a forward section and an after section just sitting there on blocks, kind of half torn apart because they've recycled a lot of the steel hull. But a lot of the internal equipment is still there. You know, it's open to the elements, it's rusted, it's a mess, but they can recycle a lot of the precious materials. And that's beginning to happen in 2020. K211 is not the only submarine that has private companies recycling them. And as long as they're recycling the materials and not digging the materials out of the ground, I support it. I think it's a good idea. It's a good program. Okay, K223, the Polsk. 1977 and 1979, she transits after her commissioning in 1979 to the Pacific Fleet stationed at a Krasnyannikov Bay. She does 5 missile patrols in the North Pacific from 1981 to 1985. Then she pulls into the dry dock in Zvezda Shipyard in 1986. Unlike other submarines, she comes back out again and conducts 2 missile patrols from 1995 to 1996, almost 10 years later. So again, these Pacific shipyards, underfunded, very slow, inefficient, poor workmanship, poor craftsmanship, poorly managed to the point of corruption level of embezzlement of government funds. Very shady, but this K223 survives all that, comes back out and is operational again in the 90s. It isn't until 1998 that she's given the honorary name Podolisk. And in 2001, she test fires an R-29R missile successfully. So she's out there on patrol, doing her business through the late 90s and 2000s. Into 2004, an air pressure reducer fails in the torpedo room, and this is scary. 4,500 pound air is reduced to 3,000 pounds, and that's reduced to 2,000 pounds, 1,000, and then you have 750, and it just keeps getting lower and lower. And these are all air reducers, air manifolds that begin at like 4,500 pounds. They're really high pressure. Well, one of these big honking blocks of metal that this air passes through as it is reduced fails. Like it just rips apart, and it explodes like a grenade in the torpedo room. The sailor, unfortunately, his name is not recorded in the logs, sees this about to happen. He's like the torpedo man of the watch. This is important, by the way. So he's in the torpedo room. He's got a couple guys in the torpedo room. He calls the alarm. He's like, get out of the torpedo room. And everybody's getting out as fast as they can through the watertight door that is in the back of the torpedo room going to the next compartment. Anyway, so he's the last guy coming through the watertight door when this thing finally explodes. And just by bad luck, of course, hits him in the back of the head, causing him internal bleeding and kills him immediately because this thing exploded. So, but he saved a lot of lives, and his name should be recorded. But unfortunately, in the source that I have, it is not. In 2006, dry dock for routine maintenance in Zvezda shipyard. They're on the Pacific side of things. 2010, she's back at sea testing R-29R ballistic missiles. In 2011, 2014, and 2015, she's conducting VIP underways for Russian and foreign dignitaries, also during war games. And so they're kind of showing off all the new modifications they've done to the Delta III, keeping this workhorse of the Russian ballistic missile fleet at sea. Kind of showing her off that even though this build is 30 years old and going, older, they're still operational, and this is why. And this is what they can do. Americans do this a lot. NATO does it a lot. I've never been on the EU boat, so I don't know if they do it, but the Russians are doing this too. And this is more of just if you can't demonstrate yourself in a real war, because obviously that's devastating, especially nuclear war, how else do you show the world how capable you are? Well, you invite their secretaries of the Navy and their admirals, and in a lot of cases, other sailors. We have a great program here in the United States where we send our sailors and officers to British Royal Navy boats for months, almost a year at a time, and they spend a year over there operating their submarines. And then they come back with the experiences that they had, tell us about it, and they do the same to us. Well, this isn't quite that program. This is bringing VIPs underway for either a couple hours or in a few cases even overnight, showing them what they can do. And they do that multiple times from 2011 to 2015. 2017, she's finally removed from service. And in 2020, her reactor is in long-term storage. K-180 Delta III, keel laid in 1977, commissioned in 1980. In 1981, 2 missile patrols are conducted under the ice. She's fully operational. In 1982, she's moved over to the Pacific Fleet, where she does a successful missile test. She operates there through the 1980s, is awarded Best in Fleet and the Courage Banner in 1986 and 87. 1991, Missile Patrol in North Pacific is done successfully with no problems. And I want to take a moment here to pause. Look at how many submarines from the Delta III we've talked about that have not had major nuclear incidents. It is beginning with the Delta III that the Soviet Navy is shedding its laissez-faire attitude towards reactor operation and maintenance. They finally get it that if they don't do their due diligence, they cross every T, dot every I on their maintenance, procedures, they're going to have these terrible incidents. And with the Delta III, we're getting into the 90s and 2000s with no incidents. And whenever they decom their vessels, they're doing it in an ecologically rational manner, even with the help of funding from Japan and the United States. Even though we're helping them with that, they're still doing the right thing. And so it's with the Delta III, they've kind of pivoted from being this almost reckless nuclear power to a more professional nuclear power. All right, continuing. 1995, she enters Zvezda shipyard for maintenance. Unfortunately, this maintenance is never finished. It is 8 years later, after she's sitting in dry dock, they finally just remove her from service. They're like, we're not going to use her anymore. In 2008, her reactor is moved to temporary storage. I was unable to confirm permanent storage, but it's been 12 years, probably in permanent storage. All right, K433, St. George the Victorious. And I want to take a moment to just talk about St. George the Victorious. In the Russian culture, St. George the Victorious is the patron saint of the sailor and soldier. So he's the guy that protects you in war and will shield you. And this submarine has that honorary name. It's a great morale booster. Soldiers and sailors from eons ago, for throughout history, are awfully, I don't want to say religious, but they're awfully, I think religious is probably a good word to use. Even myself, as I'm not very, very religious. Whenever you're about to go into a situation where, and it's combat, and there's one of two things that are going to happen in combat. You're either going to become a murderer where you're murdering people in war, or you're going to get killed. And those are the only two options. There's no other option than that, you know? So there's two horrible outcomes. And how do you rationalize that? Well, you do it by starting believing in mystical things and powers, you know, above yourself, that you're doing the right thing, even though it's about to be horrible. And you have somebody like St. George the Victorious looking over you. So this is the patron saint of the Russian sailor and soldier. This keel is laid in 1979 to 1980. She goes on 3 patrols in 2 years, 1981 to 82. Hot running boat. She is transferred in 1983 to the Pacific Fleet. She takes a Victor III with her, so presumably the Victor III transferred as well. A lot of these transits, because they're so long, are unescorted, but this is one that is escorted. In 1984, she tests the R-29RL missile. That's the one with 7 warheads. That's the scary one, because that's the one that's going after civilian targets. Because a 0.1 megaton warhead isn't going to do a lot to a shielded or reinforced military target. The R-29RL is to kill cities. Anyway, so she tests that with success. 1993, she's dry docked in Zvezdas for repairs. The repairs are halted. So while she's in dry dock is when she's awarded the honorary name St. George the Victorious. And it must work, because in 2003, 10 years after going into dry dock, repairs are complete. So George did something for him, and they start doing sea trials in the Sea of Japan. Not that they're trying to provoke Japan, but the Sea of Japan is right outside the shipyard. It's just the common sense place to do it. In 2005, she's launched the R-29R test missile, which is the regular missile. And in 2010, she takes part in Pacific Fleet exercises. 2010. Okay, so the K439 St. George the Victorious, she did a lot of Arctic voyages. Even though she's stationed in the Pacific, she's going up through the Bering Strait and doing Arctic voyages there. And here's some great shots taken from the bridge as they go through the ice. And it's very dangerous to pass through ice like this, even though the ice looks like it's kind of broken up. If you bunch a bunch of this ice up together as you're trying to push through it, the mass and weight of the ice will begin to damage your hull. Even though the hull's made out of steel, it's not impervious. So, but here you can see them doing a surface transit through what looks like a marginal ice zone. If I was the captain, I'd be looking for a place to dive really soon. All right, continuing with K433. In 2011, she collides with a small fishing trawler in Avacha Bay with light damage. It's over on the Pacific side. There's no word as to what happened to the trawler. I assume that she survived, but you can see in the picture there that the port side of the sail is smashed in. So this was no fishing boat. This was like a steel hull fishing trawler that they ran into. The next year, 2012, she fires a salvo of 4 R-29R missiles, demonstrating the salvo capability of the system. In 2013, a surprise inspection of all nuclear deterrent submarines results in a satisfactory grade and is declared the best Navy in the world. So the Navy, or the Russians, declare their Navy the best Navy in the world after the inspection. I suppose that means they didn't have any incidents. They didn't find anything. They're like, well, since we're not killing our own sailors with radiation anymore, and we haven't spilled any missiles into the Barents Sea recently, we must be the best in the world. But all the navies tend to do that. The American Navy is guilty of this as well. Of course, we call ourselves the best, and I honestly believe that we are. But we have proof to show we have some kind of material. In this case, they just had one inspection and said, well, good enough. We're the best. And I just want to point out that it's not just the Russians making declarations like that. In 2015, she completes a missile patrol in the North Pacific with no problems. So again, keeping that record up, the Delta III is a reliable operational platform. They're doing the right things. They're doing their maintenance, at least on the nuclear reactor side of things, and they're not having all these incidents. We're not killing sailors for like the first time in Russian Navy submarine history, which is great. Okay, in 2016, successful missile test of one ballistic missile, and in 2018, she is removed from service after a great career. A few hiccups along the way with the fishing trawler, but overall, a very high tempo boat doing the right thing. In 2020, she's in a Northeast Repair Center awaiting disposal. So, her reactor is still on board. Obviously, it's shut down, but it needs to be cut out. It needs to be put in long-term storage, and the inside components need to be harvested for recycling. So if you're in that business, they're looking for someone to tear apart K433. All right, so let's talk about K129. K129 is a very special submarine. It began its life as a Delta III, but it did not finish its life as a Delta III. So here at the end of the subbrief, we're gonna bring it up. This could almost be its own lecture, but I wanted to keep it with the Delta III lecture because in 1979, when her keel is laid, and in 1981, when she's commissioned, she is a Delta III. In 1984, she's doing missile patrols under the ice. In 1985, she's colliding with American submarines. She's doing all the things Delta IIIs do. In 1986 to 88, she does 4 more missile patrols under the ice. In June 1989, she suffers a power plant casualty, keeping with Russian tradition, and returns to Seven Mash for repairs. So, typical Russian submarine. In 1994, she's removed from service and begins life as a new submarine in Project 09786. She's going to become a mothership submarine to a science deep submergence submarine called the Poultice, and later on, another one called the Low Shark. So she's going to begin her life as BS-136 Special Project Submarine in 1994. This is her in dry dock undergoing conversion. This is her new look. I immediately want to point your attention to the missile deck. Look how much lower the missile deck is than it is in the previous picture. Look at this missile deck here. This is the typical Delta III missile deck that goes above the fair water planes on the sail. Now look at it. It is much shorter. That's because they ripped out the D9R missile complex. This doesn't have any missile silos in it. That entire missile compartment section, compartment 4, compartment 5, that is science, laboratory, and berthing now for all the engineers and scientists that she's taking underway with them. I want you to look also at the new shape of the hull underneath the missile deck. Going around the bottom of the submarine, you can see what looks to be flat sides. That is a docking bay for the mini subs. She can take the Poultice underway with her, just one, or the Low Shark. Here's a little drawing from the side view of her, of the Orenburg. Delta III, or Delta Stretch, is what the NATO name is calling her now. In 2002, she is renamed BS-136 Special Operations Submarine Mothership. She's the mothership for Deep Submergence Submarine Project 10831, which is Low Shark. Low Shark submarine is a deep submergence submarine with little grappling arms like they see in the Titanic movie and go down there and pick stuff up off the bottom, cut communication lines, recover missile warheads that didn't fire properly. Yeah, Low Shark is the little submarine that goes out there and picks all those things up. And Orenburg is the mothership that takes her there. In 2006, she becomes operational officially. She did some sea trials and stuff before then in 2004. 2006, she's officially doing her job. In 2012, she deploys to the Arctic Sea for months doing a geological and geographical survey where they're mapping the Arctic bottom in this high-resolution side-scan sonar using the Low Shark. Again, she can use the Poultice too. The Poultice is the older mini-sub that's been retired, but she can do either one. In 2020, Orenburg is operational in the Northern Fleet, operating out of the Kola Peninsula. Now, sadly, the Low Shark, who is the mini-sub that docks with her in that middle section at the bottom, did suffer a casualty, a catastrophic fire last year that killed all of the crew and one of the civilians on board at the time. Somehow, she managed to dock with the mothership either during or after this fire, so presumably someone survived. But she's crewed by 14 military sailors and however many civilian scientists are on her, and all of the 14 sailors in the effort of putting out this fire died of either heat or asphyxiation. Sadly, it was an absolute tragedy that happened last year. Anyway, so she is currently in dry dock, being repaired. They're going to make her operational again. As of the recording of this video, she is not operational right now, but she's definitely going to be operational and paired back up with her Orenburg mothership and doing operations just as soon as they can. But yeah, this is the AS-12 Project 1083-1 Low Shark. All right, so my final thoughts on the Delta III is, one, it is known in the Russian Navy and around the world as the workhorse of the Russian submarine Navy. And she deserves that name, because even though she was built, in the 70s and 80s, she's still working today. She has one of the best track records as far as safety and operational, deployments go of any of their programs. Russia was able for the first time in the 1980s to have at least one ballistic missile submarine at sea at all times. There was never a gap in their coverage. And the Delta III was the submarine program that brought that capability to them. She's also the most versatile submarine launched ballistic missile. She had, 3 versions of that missile. So they could send her out with a lot of small warheads, or just, one rather large warhead, or any mix in between, up to 16 missiles. She has the least number of nuclear incidents of any previous class. Like I said, her continuous at-sea presence through the 80s was key. She's difficult to track with the SSN escort. Okay, so here's the deal with the Deltas. Of course, the Deltas are quieter than the Delta IIs. Delta IIIs are, but they're not that quiet. The fact that they didn't change their engine room really hurt them. And I'm not going to go into detail. I probably will at some point, but not soon. But the Delta I, the Yankee, they all have the same engine room, and they all have the same problems. If they would just simply have changed the engine room, then at least we would have had a challenge. It would have been different. I'm not saying it would have been better, but because they used the same thing they used on the Yankee, we knew what to look for, And again, designing a submarine engine room is a big deal. That's why they didn't redo it, right? It's expensive. You got to go through testing. It takes time. It's just a big involvement. So while they're upgrading the electronics and the missile complex, the most important thing from a sonar perspective, is that engine room. And they just never changed it. So what they did is they started deploying fast attack, or SSN submarines, with them. And the point is that the American or Royal Navy would have to stay outside the escort and try and monitor the ballistic missile from an even farther distance than if the SSN had not been there, right? If the SSN's not there, we can go right up to the submarine, knock on the hatch, and be like, "Hey, how's it going, comrade?" But the escort kind of keeps us from doing that. And there's some tactical advantages and intelligence advantages to being able to go right up to a ballistic missile submarine. Okay. And we're definitely not talking about that. But so the SSN escort served its purpose. Even though we tracked both of them, and they probably knew that we were tracking both of them, it kept us from getting really close to the Delta IIIs. And they would continue this escort service all the way. They do it today. If there's a boat available, it's out there with the Delta IV poking holes in the ocean under the ice. All right. So in my opinion, this is the first modern professional ballistic missile submarine of the submarine fleet. That is my conclusion. This is what I think. The Delta III brings in a new era of professionalism, deployment capability to Russia. And, I have to give my hats off to them. They finally got it. This is their Trident submarine. Obviously it's not as good as the Trident, but this is their evolutionary Trident step. What the Trident program was for the United States compared to the Polaris program is what the Delta III is compared to simply the Delta II and everything before it. This is the beginning of a very capable nuclear deterrent.